Hey, hello, hello. Does this work? Yeah, name's Andrew. Spoiler alert. I'm talking about Bitcoin nodes, not Lightning. Hope that's not a major disappointment. So, yeah, because this is not a shitcoin conference, I guess like there's a lot more people who are more technically capable. So let's see what we can discuss and learn. So like many of you, for a few years, I've been running Bitcoin nodes on a few machines, and everything is going great. Like this particular one is a beefier one, so Bitcoin only takes about 3% of CPU and just not that much RAM. This one is a machine for like 20 years ago. So Bitcoin is running in pruning, and it's taken 20% of CPU. There's like starting to, okay, what is it really doing? But okay, yeah, this is a very old machine, and it's still working, so great. And of course, you start getting some questions when you're doing IBD, initial block download, because it has been, historically it has been getting better with newer and newer versions of the core, down to like half a day from multiple days. These metrics are for really beefy machines. So on that 20-year-old machine, it took maybe a week or more. But then, okay, so Bitcoin blockchain is less than 500 gigabytes right now. And if you do simple math, and like my fast machine was on a gigabit connection, if you do math, like, okay, this should have, like, ideally this should take an hour because initial block download, right? I can download 500 gigs on this machine in 1 hour. Why does it take like 8, 10 hours to do IBD in Bitcoin Core? Well, of course, we're not just downloading, right? We're validating blocks, right? But actually, if you take a look inside, under the hood, you have assume valid for what, since 2017 or 18, which skips at this point 750,000 blocks and doesn't validate them at all. So they, like, you install a new Bitcoin Core and you skip validating 90% of the blockchain. You just validate new blocks. A lot of people maybe don't know that, but that's the fact. So okay. Still, probably, yeah, we're not validating those 500 gigabytes of blocks, but maybe we need to, extract UTXO sets, do some other housekeeping stuff. Okay, like 8, 10 hours wasted on something interesting, but livable, because after the IBD, it's okay. It seems okay. And then, okay, so you have a few nodes running. What else can you do? Why don't you get a nice little dashboard for your nodes that people can access through, over web? So mempool is open source and it's amazing. Everyone loves it, and you can actually run it on your own hardware, on your own server. And it's kind of touted, if you go into description, it's kind of touted as being capable of run on Raspberry Pi kind of hardware. But if you look a little deeper, then to run in serious environments, which is like open to the internet, it needs something much beefier. And of course, I run Bitcoin nodes that are accessed like everyone, like you guys, when you run Bitcoin nodes, they're being accessible to the whole world, whether through clear text or Tor. So if I run mempool software, I want it to be accessible to everyone. So this is the hardware spec the author is suggesting, and by now you're like, okay, what's happening here? Like I'm running a piece of software, Bitcoin Core, that stores 500 gigs of data that is almost 100% static. Like it changes very, very slowly. It grows very, very slowly. And almost all of access to it is read-only. You just serve static data from hard drive or SSD. And then you want a dashboard on top of that, just to graph out what's happening. And you need this kind of hardware. And this is, of course, by no means this is like super beefy. You can have a server that is like 100 times bigger and better. But this already puts a lot of limitations on the amount of people who are willing to run this for free, or just out of curiosity. So what's really happening here? So this is what I want to talk to you about: the intersection of security complexity and performance in Bitcoin software, Bitcoin protocol, different Bitcoin nodes. What's happening? But first, I want to tell you a little bit about myself and what kind of perspective I'm coming to all of this from. So yeah, name's Andrew still, but I was very lucky in my journey in life. When I was in high school, we started a small ISP with a few friends, and we knew nothing about computers except how to run games. So we started running the whole networking infrastructure using Windows. Quickly, maybe over a year or two, we realized it's really unreliable. So we started looking into better stuff. Ended up realizing that we need some kind of Unix. And almost by accident, I stumbled into FreeBSD just because it was really hard to find good documentation how to set up networking daemons for any flavor of Linux, although that would be my first choice. And somehow FreeBSD seemed ancient, but the documentation was amazing. You could read the whole handbook in one day and set up everything out of the box. Yeah, so we upgraded the ISP with this Unix technology, and everything got much, much better. But then I was fascinated with this kind of tech. I started digging deeper and started contributing to the project. And I learned a lot. I learned that Unix as a family of different pieces of software, and specifically its BSD branch, and FreeBSD later, it's one of the biggest and longest running projects. So Unix itself started late 60s, and then BSD at Berkeley, they started coding it in 1975. And it's still going, it's very active. And the magic about projects like this is you have people like this, not the one on the left, the one on the right. That's Marshall Kirk McCusick, who started coding BSD in around 1975 and still does. He commits every week. So that's 50 years, maybe 30 years when I joined. And you can't replace that kind of experience with anything else. So and there's dozens of guys like him. And of course, people with that kind of experience, the projects delegate the most conservative and dangerous pieces to them. So McCusick has always been in charge of the file system. He built FFS, which was the most innovative file system for a decade, then UFS, then UFS2. So you want people like that to do that, because your computer or network can crash, but one thing you don't want to lose is data. You don't want your files corrupt. And again, there's dozens of people like that. So once you start learning from them, you realize they've been through a few cycles, right? Kind of like with the economy, you listen to people who've been through a few cycles, and they tell you, okay, this is something I've seen in 1980s, and they explain why. Same in technology, there's always these cycles, and for many of us, we see a new thing, and it seems new, and they explain to you, okay, exactly what's happening now and what's going to happen in a year with this new technology. JavaScript on the rise. Okay, this it's going to take 5 years to build up the collection of standard libraries and so on. So this is very valuable experience and is a shortcut to mastery. Right. So another thing I learned is how large and stable open source projects are organized and successfully operate. So in case of FreeBSD, it looks very democratic. So, and you'll see parallels to this in Bitcoin. So there's like a core layer of like hundreds of committers. I think this from a decade ago. By now it should be like double that. That have commit access. They can actually commit to the tree. So right now everyone is on GitHub or at least like Git somewhere. But you know, if you look over the last 50 years, there's been maybe 5 or 6 transitions from system to system in terms of version control. So right now you would say like, you know, a few hundred people have access to the GitHub. And from them, in this particular project, they elect a few core members, 9 core members every couple of years. And then on the bottom, you have thousands of contributors who can contribute what you now call a pull request. But you know, in like not so long ago, it was just patches, send patches, and then some of the committers would look at them, request some changes, and finally, if it passes, commit. And there's some specialization among committers. So there's some that specialized in kernel, and this particular operating system, it's so Linux is like a kernel separately, and then there's GNU userland. But this particular project is more monolithic, so there's like kernel and userland is inside the project, and then there's documentation team, separate documentation committers, right? So at the time it was like 40. I think by now it's like 100 people almost exclusively working on documentation, and probably that's why that was the reason why the documentation was so impeccable, like better than any book. And then ports is like the team that is porting packages, so package management team, porting thousands or by now tens of thousands of packages into the system, interfacing with those tens of thousands of external projects, making sure everything interoperates. So sometimes they do go fix the system, like even the kernel, to make sure a third-party piece of software works. Sometimes they go fix the package, and on top of that, they also do security management. So it's with every serious operating system, like Debian or Ubuntu or FreeBSD, they track vulnerabilities, security issues for each one of the packages. So like 30,000 packages, you do your best to track security issues for all of them. And like you have like a serious operating system, so you have like a set of practices to do that. But among the packages that you have, 90% of them will not have those practices. So you have to learn very, very carefully. So in the whole project, you also have a security officer and a security team. So the officer is in charge of the team, and they all work together to achieve like this maximum security. Yeah, how these organizations work, also very interesting. Like when you start going open source, you start asking questions like, why are you doing this? How are you doing this? Like, who pays you? Who's paying you? Who's like paying the bills? And there's a whole spectrum of answers, like I'm doing this in my free time, or oh, actually I work for like IBM and they let me do this full time. During my work hours, or something in the middle, or like contracting, or so there's a spectrum, and you start to learn there are different motivations. Like a lot of people do that just because they're really interested. For a lot of people, it used to be a professional job, a professional interest, and then they switch jobs to something boring or something different, but they want to keep up doing like the previous interest. So a lot of different motivations, and definitely like almost never money is the driving motivator, but always like a supporting factor, and only for a fraction of those developers. Right, so I did that, then like a few years later we did a startup, music streaming, large scale. We managed to hire this guy who's creator of Nginx. So his one focus in life at the time and later was to build a web server that can deliver massive assets to a massive number of users with highest possible efficiency. And we learned everything we could from him, and together we designed a system that actually later he incorporated Nginx and consulted and Netflix. So we designed a system, an open source content delivery system, which was 20 times more efficient to deliver massive amounts of data. And he later introduced Netflix to it, and they actually still run. It's called Netflix Open Connect architecture, and by now I think in the last 10 years they optimized it to a way that a 1-unit server can serve up to 400 gigabits of traffic per second. That means if you like use it for something dumb like initial block download, you can do that in like under 10 seconds fully from one server. A few years later, with some friends, we started a hardware wallet company. We did, the second, I think, after Ledger Unplugged, NFC hardware wallet, and we had some fun. We did a smart banknote, like bearer asset, NFC bearer asset. I think the first one, which was really usable for consumers. And I was very lucky because that brought me into touch with thousands of people who were in the process of being onboarded into Bitcoin and really understand the spectrum of challenges they face, like the worries or the troubles with UX and all of that. But also we, of course, as a hardware wallet company, we had to do deep dives on all the hardware issues, like secure hardware issues, but also software wallets, because we were considering to integrate and all that. So that brings me that triple exposure to relatively massively successful open source projects with high longevity, plus industrial scale, let's say data transfers and databases, and that a few years of deep dive into consumer side Bitcoin experience led me to this. So I realized I need to dig much deeper into Bitcoin core and Bitcoin protocol and understand the bottlenecks and how to overcome them. And this is the basic model I have in my mind for when thinking about a piece of software which is reasonably mission critical, which does require significant computing resources. So security and performance are always the goals you're going for. And you can is this a multiple or a single choice triangle? It kind of is. So, but who would choose complexity, right? Complexity is never good. Well, the problem is complexity is gravity. So by default, whatever you're doing, everything degrades. By default, innovation does not happen. The opposite happens. Entropy happens. So, and by default, your lines of code, the count, it grows. You start sacrificing both security and performance. Your overheads grow, and so on. So there's this thing called Tesler's law. So Larry Tesler was an engineer at Xerox the famous lab that invented graphical user interface, mouse, and that Steve Jobs copied everything from. So he was working there in mid 80s and realized there's this law. It's also called complexity conservation or preservation law. That every task has an inherent minimum complexity, and depending on how you do things, you can either hide more of the complexity inside the app and leave less of it to the user, or you can build a less complex app and leave more of the complexity to the user. And of course, there can be more components. So sometimes web designers, they say, okay, there's like browser, web app, and user, but this is the basic. So you can never compress complexity. You always have to like split it between the app and the user, but you can never avoid it completely because some tasks are really complex, and you have to just represent them partly on the computer, partly inside the user brain. But the thing with Bitcoin is, at least in the current iteration of Bitcoin, complexity is security. So because like the only function of Bitcoin is secure your financial savings and transactions, and even by now we all understand that if you completely want to avoid Bitcoin and opt out, you still lose. So in the future, maybe there's going to be another model, but for now, it is like that. So security, it means split, like the complexity of security is split between the Bitcoin system and the user. But of course, Tesla's law talks about the minimum complexity. This is the optimized case already. What we have in reality is probably more like this. There's a minimum complexity that we have to deal with, but we're not even there yet. Both the Bitcoin system and the challenges that users have to grapple with are much more inflated or bloated than they have to be. So how do we get here? And this is one of the visuals that for non-technical people is like, wow, Bitcoin going up. For any engineer, this is like, well, what's happening? Like, this is the growth in lines of code in the Bitcoin repo, the master branch over the years. And you can see, of course, that there's like, until Satoshi left, it was like growing slowly, manageably, and then after he disappeared, there's like kind of an explosion. Fortunately, this is a linear graph, so it's still capped at linear growth. We almost went exponential at one point, but thankfully somehow kept it. And like you're like, maybe this is normal, right? Because like, okay, Bitcoin is growing. Should we do like more features inside Bitcoin Core? This should be normal, right? So there's nothing wrong with that. But this is like security software. This is security software, and when you asking like a lot of people in technology that don't have much exposure to security, they don't think about, they don't think in terms of perimeters. They think in terms of features. They don't think attack surface. They think like, protection, defensive measures. So 600,000 lines of code, that's 600,000 questions of, how do you lose all of your money? And it's not about majority hash power. It's really, it doesn't have to be that. Majority hash power is like one line of code out of this 500,000. Also, this is not a perfect metric. Don't take it with a grain of salt, with a grain of salt, because of course a lot of this code is testing or like documentation or kind of ancillary code. It would be better to kind of find out exactly which parts are critical, mark them, and count them. But still, even if, testing, but it's still part of the Bitcoin package, right? Is it useful? Do you need to test your Bitcoin releases? Yes. So you actually need to understand what's going in your tests. And just for comparison, this is libbitcoin system, which is just part of everything libbitcoin is doing, one of the alternative projects, like together with a couple of other repositories, they have a full node. Also growing, right? A slightly different, slightly more granular and shorter history. So due to whatever reasons. And this is just for reference, not gonna talk much about shitcoins, but Go Ethereum, it blew up. And they cleaned up some code down to, it's down to also like similar to Bitcoin Core around 500,000 lines of code. And actually, half of them are like JSON data files for testing, but just for reference. So that was internal complexity. And then maybe you have a question, okay, what is the external complexity that Bitcoin is, let's say, inspiring or necessitating in the world? And just a quick way to estimate that is like patents. Patents are completely outside of the Bitcoin Core project, of course, but they're kind of a proxy. What's happening in the world? Because there's a barrier to filing a patent. It's not free. It's not all spam. And by the way, I checked. Not all of them are filed by Craig Wright. And they're not slowing down, actually. It just takes a few years for a patent to be published. So I think it's like the counts are going to be higher in the future. And while we're here, it's interesting that if you look at patents for like containing Bitcoin keyword, this kind of US is #1, followed by China. But if you collect them, then China, Korea, Japan, Taiwan, the non-English speaking patents are much more numerous than English speaking patents. It is like interesting. Maybe it's cheaper to file patents there or something else. And as a final point of amusement, if you look at Google patents for Bitcoin before 2009, there's actually a bunch of patents, and they're all not written in English, but from my understanding, the Asian languages, they got so polluted with Bitcoin and their non-Latin word for Bitcoin, then Google patents now automatically translates old patents as far as like 1950s, and recognizing old words as if they would be referring to Bitcoin, which is a bit hilarious. So, so once you start looking at Bitcoin code history, but like just code of whether the current version, but especially the early versions, a lot of engineers who kind of are comprehending what's happening there, they like many of them have a semi-religious experience. And yeah, this is from like some discussion with a quote from 2013, apparently from a reasonably popular and smart person at the time on Bitcoin Talk. I don't know, maybe one of you. So yeah, I'm going to quote. The first time I learned about Bitcoin, I took a look at the white paper and code, and I found all kinds of flaws. It wasn't until days of reading and researching that the elegance of the solution became visible, like a Polaroid appearing from the black. It's humbling when you realize that you're looking at the product of someone far above your own capabilities, and they have created what you previously considered impossible. In 100 years, in 100 parallel worlds, I wouldn't have come up with the concept of Bitcoin. It was simply too alien. It goes beyond just intelligence. The idea was simply outside of my frame of reference. The problem wasn't even when I considered that a solution existed. So that's like one religious experience. To many other engineers, it's more of a religious experience of contradiction. Like to me, it's like I can't believe this is working because it's crazy how many reasons you can come up with that these can't work. Like not the first versions, not the early versions, not the current version. Like there's just too many. That's why if you go on Hacker News, the sentiment towards Bitcoin is like 95% negative. Like for any mention of Bitcoin on Hacker News, there's going to be 50 brilliant engineers explaining you in detail why it can't work, and still it does. So I don't know. Like I personally believe that maybe Satoshi was possessed or something, but it doesn't feel or look human. But now it seems to be in human hands. It's kind of like, this is, you look at a burning bush and like it is burning, but it's not collapsing. So there's like, also like, of course, Satoshi himself, he collected roughly off-the-shelf components, right? OpenSSL, like existing elliptic curve with some consultation, like all of that. So kind of like the iPhone, nothing much original, but the integration of all those parts, they're like, it's like a coincidence on the order of like 10 times in a row you choose right. So very, very weird. But then when you dig, then you see all the the other side, the human side. And the human side is like, yeah, the human side is lots of flaws like this, which some of you know that, initially Bitcoin was infinite inflation. So every 250 years, we get another 21 million coins. And then you have all these vulnerabilities, and this is just a tiny portion of them, because like early on they didn't even count them or didn't even describe them, but they continue to this day. It stabilizes. It is stabilizing. It's like less Wild West than it used to be, but it's not like like a lot of people have this. They confuse two concepts. One is like the ideal concept of Bitcoin, which is, let's say like in a Christian church, it's like God up in heaven. But then there's like the church on earth, and there's priests, and they do like, they make mistakes, sometimes very horrible. And a lot of people, when they say, okay, this is the solution, like Bitcoin is like fixes this, they mean well, but they mean the ideal concept without actually, implying that the reality, the current reality of Bitcoin, is a much more complicated issue. Yeah, and again, when you like think about security issues, most prominently in other, in shitcoins and non-Bitcoin projects, where there's like, it's glaring when you talk about security. Instead of showing you that they have actually thought about a perimeter and a threat model, they say, oh yeah, we have like a couple of security features, but that's not how you can think about security, because like it's like one of those Bluetooth-enabled smart locks that has military-grade encryption, but you can actually slap it with the back of your hand and your door is open. So security features are not enough. You have to have a threat model. And last time I checked, let's say like hardware wallets, maybe one or two of 100, the top 100 of them had a published threat model. When you look at software wallets, I think 0 of them has a published, maybe also 1 or 2, a published threat model. And that is like for software, that is like a a real life bridge that if it collapses, people more or less die, or some proxy of that. It's less than acceptable. So what else is happening? This is the number of core developers. I think there's like just the count. This is the graph from NYDIG. They did some research on Bitcoin contributors. I think this is like the people who got accepted pull requests in any particular months. It is growing. So it was quite tame again until like while Satoshi was kind of there and kind of in charge. And then like, lots of spikes, slight correlation to spikes in the price, but mostly just growing. And most of these people are smarter than most of us, definitely than me. But like, is there a distribution curve? Then you have like concerns like this, and this is where the experience with large open source projects where like nobody is primarily motivated by money. Same here, same for Bitcoin. If you look at core devs who, whether they had funding or not, they were never primarily motivated by money. Otherwise, they would switch to shitcoin long ago. But still, when you kind of start thinking about Bitcoin in this frame of reference, something feels off. Then there's like infamous Dunning-Kruger, where the stupider you are, the more you think you understand. But the critical thing to understand about this is it's multidimensional. So especially once the project gets bigger and you have to have areas of specialization, you're going to be on the right side. You're going to be very smart and know exactly how dumb you are when you're very specialized and the master level expert. But in all the other areas, you might be on the left side of it. So let's say you're like a world-class cryptography expert and you're working on Bitcoin, whether like episodically, maybe you're a new contributor. And yeah, with like cryptographic functions, you're unparalleled, you're God. But you know, Bitcoin is an integrated project, and you have to sometimes think how does it affect network performance or something else, or like the economy of Bitcoin. And you're gonna think you understand, but no, you're just super dumb on that dimension, and have to keep track of what's happening with campaigns to Bitcoin, and like, is it really like, is due consideration to those effects given or not? Luckily the guy that tries, like, it costs 200 million a year to keep Bitcoin code maintained. He doesn't know what he's talking about, but if this becomes true, then probably game over. Like, if this is a fixed cost to maintaining the code base, which if we keep growing the code base, we would probably reach it in a maybe decade or two or more. But if this is reached, probably not so good, because like any fluctuation in price or the economics of everything, and it breaks. So this is what I believe, that the same reasons that we choose to limit the block sizes, to make it manageable for everyone, for as many people as possible to run a node, like bandwidth, hard drive space, even more critical to manage the complexity of Bitcoin to fit in a human brain, or to maximize the number of human brains who can comprehend Bitcoin, like enough to keep track of what's happening. And let's see, so Bitcoin white paper is like famously just 9 pages, but of course it doesn't define Bitcoin. Like, what defined Bitcoin was the code, and as of now it's Bitcoin white paper plus 500,000 lines of code plus 160 bips. Okay, maybe over 160 bips, a lot of them are rejected or irrelevant, but it's still like the definition of the protocol. Like, if we don't have a real spec, this is a lot. And for comparison, of course, there's Ethereum, who's a multiple of that, and Ethereum is getting to this, right? The Vitalik is, really loves this graph. To an engineer and me, okay, yes, there's a big chance that every component here I can go and click and understand, and in a month I can understand all of it. But intuitively, I'm 90% sure that there's no one in the foundation or like nowhere who can understand even a third of the current Ethereum complexity. So this is like, nobody can comprehend this, trust us. And we don't want to get here. We really don't want to get here. So zoom out a little bit, right? So if you compare gasoline cars to electric cars, it's like a 10x reduction in moving parts, 3x reduction in total parts, and same with Space Shuttle was mind-boggling, right? 2.5 million moving parts. Yeah, I triple-checked that, like moving parts, 2.5 million moving parts. Whereas SpaceX rocket, I couldn't find like first-party data, but ChatGPT estimated at like 100K total parts, moving plus fixed. So yeah, what happens when you have a lot of moving parts and total parts? With Space Shuttle, it's crazy expensive and you die. Same in gasoline cars, like they're heavily subsidized by whatever oil, and it's like inkjet printers. You sell a gasoline car, but all of your profits are in the service department. But with Tesla, they're safer, they never break. So to me, especially shitcoins, but even Bitcoin right now, it's in the territory of a lot of moving parts, a lot of exploration, and there's no Elon Musk to come and say, okay, the next version, we're going to reduce the number of parts by, you know, for every new part you're going to introduce, you have to remove 3 parts. Like there's no Elon Musk, there's no leadership like that. There's a nice little, like there are very, very smart people managing the code right now, but they're not dictators by any term, and there's like, you know, the whole kind of Western wokeness environment forces everyone to be very nice to each other. You know, if Theodore of like, you know, like OpenBSD came, or even Linus, and starts telling everyone exactly what he thinks, what he or she thinks, there would be newspaper headlines, oh, whatever, like abuse of developers. So, yeah, a lot of people say, oh, it's open source and there's lots of incentives. Just two quick also examples. OpenBSD is like very secure operating system, but every single time they do an audit, they find more critical security issues. One of the times it was like very hilarious. There was like a leak. One of the previous developers said, oh, actually 10 years ago I was being funded by the FBI to introduce backdoors into your IPsec code. And they started an audit. They proved that he wasn't funded by the FBI because he didn't introduce any security issues, but they found 3 other major security issues in the same code that were like completely unrelated. And closer to Bitcoin, Satoshi Labs, and closer to what I'm familiar with, they, when they were building their hardware wallet Trezor, they looked at secure elements. They almost went for one of them. All the security elements currently in the world, they require you to sign like, you know, 500 pages of NDA that are watertight. You really cannot cross them. And once you do that, once they did that and they looked at the chip, they realized, wow, there's like, they have more security issues than you know, any insecure chip. And that's why they started their own company, their own chip. But this is for places that you're sure, you're certain that they're more secure because they're open, or there are a lot of incentives. Like the chips they looked at, they used in, you know, stuff like credit cards or secure servers. There's like billions of dollars behind them also. So it's not like non-Bitcoin where it doesn't matter. It's there's a lot of incentives. So yeah, secure platforms are great, but like all of them have issues. And when you have a huge attack surface, like you can guarantee you have like a ton of security issues. So why like with all that complexity and it's growing, why are we not pwned? Why is nobody massively yet owned? Well, there could be a number of issues. I think the number one reason we're not like owned on a massive scale in terms of like Bitcoin bugs is it's much easier to just scam people in DeFi or to just hack the DeFi micro. So we have to be grateful for that. So yeah, so back to mempool. I'm gonna like accelerate a bit. Back to mempool. Like what's happening? Why is this all of this? Why does mempool software require so much? So Bitcoin is like 3 transactions a second still, like 500 gigs of data. It's like nothing. It's like 1 billion of total entries in the transaction database. For any database administrator, for any pro, this is trivial. This is like, this can run on a decades-old server with 0 CPU. Even like 3% CPU usage on a modern server, like on a modern beefy server, like what? 3 transactions a second? That should be 0. And you know, if a real database was used, you could replace like Electrum servers and a lot of other servers around Bitcoin Core. They're just there to introduce a single new index, address index. And actually, there was like somewhere in slides, yeah, there's for maybe by now like 9 years, there's been attempts to add address index into Bitcoin Core. For good reasons, it's shut down because in Bitcoin Core, the whole database is implemented manually in C++ or like based on key value stores, like, you know, initially Berkeley DB and now Level DB. They actually just introduced SQLite into codebase for wallet dat, but they don't use SQL because that would break backwards compatibility. So yeah, I think like lack of real database technology behind a product that is essentially a big database could be a problem. So again, like Electrum could be probably like a few statements in SQL. That's it, like a new index and a few statements in SQL. But instead of that, you have like Explorer, like Blockstream Electrum server that requires a crazy amount of resources. Let's see. Yeah, actually, like a lot of companies before they started, this is like from Coinbase in 2014, and they basically translated Bitcoin Core into Postgres, but they used Ruby around that, and of course it didn't scale well, but they're still using that. They just had to expand it to shitcoins, and now it's closed source, proprietary, and Coinbase Cloud. Not sure who would use that. Fortunately, there's more. I know there's at least Hugo of Nunchuck who is like against alternative nodes. But at this point, I believe, at this point in exploratory growth, we need more alternatives, at least to explore solutions. But James and Lop is doing good work benchmarking them every year. And it appears like currently Bitcoin Core is one of the best, although like GoCoin claims to be slightly better in recent commits. So it's possible, like you can, without too much effort, a single person can do IBD twice as fast as Bitcoin Core with like every security measure same. That was like libbitcoin, early version was also basically Postgres and a few like C++ libraries around that, but it got pivoted to something else. And a lot of people complain that, oh, usual databases are too slow, but actually they just don't optimize. Like for that music streaming service, we did like some optimization hash types for Postgres, so you can store SHA-256 in a database much more efficiently, unrelated to crypto, right? But I was surprised to learn that a few years after that, some Bitcoin company picked up that library for their Bitcoin project. So it's possible with very little effort to optimize and to achieve like amazing speedups. Yeah, so let's skip a little bit to the end. Yeah, to people who you know, like many of you know already, like almost everyone I'm talking about. To people who don't, this book is great. It came out last year by Bitcoin: A Work in Progress by Yours. It's a primer, so it will like if you're an engineer, it will make your hair stand, because you know if Balaji is screaming, you know, bit signal, the world is dying, go to Bitcoin. An engineer in me sometimes is like, okay, yes, a billion people is coming to Bitcoin. No, we're not ready. Wait. So like I feel similar anxieties in Bitcoin, but if in financial world there's like thousands of people are exploring that, in Bitcoin not enough people are exploring this rudimentary problems. And for me personally, I'm still an independent researcher. Very lucky to be able to self-fund myself for a while. I keep exploring how to apply like real database tech, like indices to Bitcoin blockchain data. And especially, I think we need to arrive at one last point, maybe at documentation, because in Bitcoin there's like two levels of consensus. One is on-chain, that kind of everyone knows about, but the other is when you read Bitcoin Work in Progress or you read the history of Bitcoin, there's a much more important level of consensus that's human consensus. And currently you can't like you can't really run a node and like without your human supervision that decides which software to upgrade over time. You're mathematically guaranteed to lose everything. So it's like the on-chain consensus is not enough to keep everything. You have to keep track of human consensus that decides soft forks, hard forks, and all of that. So with we do probably need to refine the protocol spec at some point, because right now the code is the spec. It's not even the bips. It's the code only partially described as bips, and that's a problem. Okay, so I think I ran out of time a few minutes ago. Maybe one or two questions.
Yeah, you can do Q&A now. You can move to Q&A.
Yeah. So yeah, Larry.
Thanks for an awesome talk. There's so much data. I want to go back to something you mentioned earlier, and also at the end, which was the idea of the complexity being like at the code layer and also at the human layer and the user layer. What would you say, and maybe this is really hard to answer, but what is like a minimum amount of complexity a human needs to hold in their brain about Bitcoin to keep so that it stays secured? I don't know if that question makes sense. But so I mean, just to follow up, like, because a lot of the people we've talked about, you know, they're building on Lightning and they're trying to like hide complexity because there's a lot of complexity. But in terms of Bitcoin, like, what could we, like, is there like, what if 99% of the people in the world never know about the on-chain consensus? Will it still succeed?
So I don't know. That's a very good question for exploration and mathematical modeling. Like intuitively, it seems we need a spectrum. We need a spectrum of solutions where, you know, some people, like we need like one Binance and all of the people on Binance, like, you know, doing everything off chain seems simple for them, but it's horrible. So if we had, let's say, 1,000 Binances or 1 million Binances, all with different problems and all with different risks, it would be much better. So like kind of cluster centralization into more independent parts, that would be like systemically it would reduce risks. But I think even before that, we need a lot more capable people to learn about Bitcoin internals. It's unacceptable that like 40 people are contributing a month. We need like hundreds or thousands of people at least to start looking at internals. It's very scary that is not the case today.
Good question, good answer. We have time for one more before a 10-minute break. Any hands, any takers? Yep, we got one there in the crowd. Right, give that gentleman a mic.
Yeah, maybe this isn't an easily answerable question, but how do you get to thousands of people contributing and not have that lead to more complexity? Because each person you add to, you know, Bitcoin Core contribution is probably going to bring a bit more complexity.
So hopefully, first of all, hopefully like just mostly reading and researching and maybe writing about it. We already have a lot, like, you know, the Bitcoin documentation is right now, the books, right? Mastering Bitcoin, Bitcoin in Progress, the books by Eric Voskuil, the collection of his musings. So that's a good contribution, but without bloating the code. But you know, for every 1,000 or whatever, million people who add bloat, there's somebody on the spectrum closer to Elon Musk who comes and solves more problems. So until you grow, you will not find those people. Yeah, so we definitely need more. We need to grow the pool to find outliers to the right side of the spectrum, something like that. But yeah, it's a real risk. You can't just expand it like, you know, start hiring everyone. There should be, it's also has to be self-filtering. Like if there's like a Blockstream announces that they can hire 200 people, staff to work on Bitcoin, that might be horrible. But if people are self-filtering and kind of starting contributing or at least reading code for free just because they're really interested in this and passionate, that's a much better filter than just chasing a few bucks. Okay, cool.
Agreed.
Thank you so much.
Agreed. All right, everybody. So we're going to give a round of applause